How does it trap all this chaotic energy so perfectly and so reliably across the entire cosmos? That brings up the architecture of the strong nuclear force itself. We're very familiar with gravity, and we're familiar with electromagnetism, which operates on positive and negative electrical charges.
Right.
But the strong force doesn't care at all about positive and negative, does it?
Not in the slightest. The strong force operates on an entirely different, incredibly complex property, which physicists whimsically named color charge.
Now, for anyone listening who might be newer to chromodynamics, it is vital to emphasize that this has absolutely nothing to do with visual colors.
Quarks do not possess a microscopic pigment. They are not actually red, green, or blue.
It's just a naming convention. Physicists needed a way to describe a force that operates on three distinct types of charge, rather than just the two we see in electromagnetism.
And since the mathematical rules of how these three charges mix perfectly mimic how the primary colors of light mix, they just borrowed the terminology.
Precisely. If you mix red, green, and blue light together in equal measure, you get white light. It appears colorless.
And that brings us to the most unyielding rule in the cosmic recipe book, the rule of three.
The dress code.
The literature makes it explicitly clear that for energy to be perpetually sustained in a mass form like our highly stable proton, the resulting composite particle must be perfectly colorless.
It must be what is known mathematically as a color singlet.
Exactly.
So the bouncers at the door of this Proton nightclub enforce an absolute, non-negotiable dress code. You can only enter and form a stable system if you bring a perfectly colorless group.
You need exactly one red quark, one green quark, and one blue quark.
If you show up with two reds and a green, the universe rejects you. You are unstable.
That requirement for color neutrality isn't arbitrary. It is governed by a highly specific mathematical blueprint. The research refers to it as the geometry of reality.
The geometry of reality.
Specifically, it is governed by a continuous symmetry group known as SU3, the special unitary group of degree 3.
Let's unpack the logic of SU3 without diving into the matrix calculus. Gauge symmetry can sound intimidating, but conceptually, it is essentially the underlying mathematical rulebook for how these color charges are allowed to interact and swap places, right?
That's an excellent way to conceptualize it. Imagine an incredibly fast, complex dance inside the proton where the quarks are constantly changing their colors.
Changing colors, okay.
A red quark emits a gluon and tosses it to a green quark. In the process, the red quark transitions to green, and the green quark absorbs the gluon and transitions to red.
They swap.
The SU3 gauge symmetry is the geometric blueprint that dictates every single valid move in this dance, ensuring that no matter how frantically the colors swap, the overall macroscopic state of the proton remains perfectly colorless at all times.
And because there are three fundamental colors, red, green, and blue, this geometry mathematically dictates the exact number of gluons required to facilitate all these color swaps.
Yes. The mathematics of a 3x3 symmetry system dictates that there must be exactly 8 force-carrying particles, 8 distinct gluons.
Okay.
These are the 8 unique combinations of a color and an anticolor that can be exchanged between the quarks to keep the strong force operating and the symmetry unbroken.
Wait, let's look at the basic arithmetic of that for a second. If you have 3 primary colors, red, green, blue, and 3 corresponding anticolors, anti-red, anti-green, anti-blue, shouldn't there be 9 possible combinations?
That's the logical assumption, yes.
You would pair red with anti-red, with an anti-green, red with anti-blue, and repeat for the others. 3 multiplied by 3 is 9. So why does SU3 only allow for 8 gluons? Where is the 9th gluon hiding?
This is one of the most profound reality-saving quarks highlighted in the research. The math does indeed generate 9 possible pairings. 8 of them form what is called an octet.
The octet.
These are the gluons that carry a net color charge and actively participate in the color-swapping dance. But the 9th combination is different. It forms a singlet state.
A singlet.
Mathematically, this 9th state would be a perfect, symmetrical, equal mix of red anti-red, blue anti-blue, and green anti-green.
Which means, if it's a perfect mix of all the colors and anticolors, it would be totally color neutral, all on its own. It would be a white gluon.
And remember the fundamental rule of the strong force. It only interacts with things that possess a net color charge. If this 9th color-neutral gluon actually existed in nature, it wouldn't feel the strong force. It wouldn't be bound by the rules of the nightclub. It wouldn't participate in confinement.
If it isn't bound by confinement, what would it actually do? Where would it go?
It would leak out of the proton entirely, Because it has no net color charge, the strong force couldn't trap it. It would radiate outward, flying through the vacuum of space, much like a photon of light does for the electromagnetic force.
Okay.
But unlike a photon, which only interacts with electrically charged particles, this unconfined gluon would carry the strong nuclear force over massive macroscopic distances.
Oh, that sounds catastrophic.
It would be the immediate end of reality as we know it.
Wow.
The strong force is exponentially more powerful than gravity or electromagnetism. If a long-range strong force existed via this ninth gluon, it would cause all the ordinary colorless atoms in the universe, the carbon in your cells, the oxygen in the air, the iron in the Earth's core, to violently interact with each other at a distance.
This is a universal crunch.
Macroscopic matter would simply collapse under the overwhelming attraction. Planets, human beings, biological chemistry, none of it would be possible. The universe would instantly crush itself into a chaotic, ultra-dense soup of violently interacting subatomic sludge.
So, to save reality from immediate collapse, the universe basically audited its own math, realized the ninth combination would destroy all macroscopic life, and implemented a strict geometric exclusion.
Exactly.
It demands a traceless matrix. Every single gluon that exists must carry a net color charge. No colorless gluons are allowed to manifest. You must be locked up or you cannot exist.
The elegance of the SU3 blueprint is that the mathematics inherently require the generator matrix of these interactions to be traceless, which permanently and naturally excludes that highly destructive neutral ninth state.
The universe utilizes an exclusive 8-part code to ensure every ounce of energy related to the strong force stays completely confined within the boundaries of the proton.
Knowing the mathematical rule is one thing, but how does the universe actually enforce this confinement physically?
Right.